So what's happening here? The idea of using a network trained for some other task for generating representations or features for a given task is called transfer learning. Right now there are some terms. So the network that we are using for generating features is called pre-trained model. The task that we are trying to accomplish with these features is called downstream task. I remember these concepts. Getting it? So we talked about these three important concepts. Now the next question is, how do we get these models? Which models? How do we get these pre-trained models? Of course, again, there are two choices. One is we train them ourselves, or we use someone else's model for which the architecture and weights are available. Right. So of course, this particular thing is difficult, owing to, see, we talked about web scale training of the model to predict next word, right? Now, in order to train that type of model, which has so much of training data and complex neural network, we will require huge amount of computational resources. We require huge amount of compute resources. And it is also very expensive to train these models. So it is not efficient to do it for our problem. So this is difficult owing to high compute cost. So we are going to use this route. This route is very interesting, where we are going to use someone else's model. We are going to use someone else's model where architecture and weights are available. So we are going to use these type of pre-trained models. Okay. So the flow will be as follows, right? So let us quickly write the flow. How are these things going to proceed? Okay, so let us write down the flow of these things. But before that, we'll write the flow of the traditional ML, right? Traditional ML. What happens? We have data, we have features, we train models, and we evaluate. And now how the new flow is going to look like? Let us write this flow. We are going to have data. Okay, then we'll get output from pre-trained model up to selected layers. Okay, this becomes our features. And then we have so between these two, let's see what changed. So we had features here. Pay your attention to this. Now we are going to get features from this particular step. Where we are going to first select a pre-trained model. We are going to decide up to which layer we will use this model to get the features. We train the model and evaluate it, right? So this is traditional ML. This is using deep networks as automatic feature extractors. Unfortunately, these type of models are available. There are open source repositories where these such kind of pre-trained models are available. So there are pre-trained models available for vision, audio, text, also for NLP. So all these type of pre-trained models are available. So what we will do in the next class is we will perform hands-on experiment with each of these model. One example at least from text and image we will do. And then as a homework, you can do the same thing with audio and video, where we will provide you with the pre-trained models for audio and video. And we'll experience this particular thing. So what happens is typically, right, how our pipeline will look like. I'm going to just give you some code snippets right now, but we will do more thorough job in the next class. Code snippets for transfer learning, right? So let me write down some code snippets, which will be very useful. Okay. Let us make this as a sub part of. Okay. So let us write down some of these techniques. Here's example code for text, for example. A lot of things will not be known to you, but we will do it in the next class. I'm just putting this snippet just to explain how the flow is end to end. But we will actually do this in the collab in the next class, where we will code this up and we will do it step by step. So here what is happening is that we want a model, right? Pre-trained model. We now know that we need a pre-trained model. So we are going to choose BERT as a model, as a pre-trained model for this task, where we want to basically represent this particular text with features. So we'll see how to do that. So we use BERT as a model. So this BERT model comes up with its own tokenizer, meaning that it needs to know what type of tokens it should be forming from this text. Token need not correspond to the word. The token could be THI, another token could be S-P. These type of tokens which BERT has already learned from its own corpus, we are going to use the same tokenization. We are going to use BERT model for pre-training. We're going to take this sample text, and what we are going to do is we are going to first use this tokenizer and encode this text. Right? So this is part of the input to this BERT model. We are going to encode our text using BERT's tokenizer, and then we are going to pass this input into the model and literally get the output of this model. So you can think of this as a prediction, but we are not going to get a final prediction from the model, but we are going to read out the output of, let's say, last but one layer of the model, right? And we call it as an embedding. Right? So we get embedding for every word. We are going to take average of these embeddings, and that becomes embedding for the entire sentence. So this is one way of doing it. There could be multiple ways of doing it, but here we have taken mean as a very simple way to average embeddings for every word, and this becomes the embedding for your statement, for your sentence. Now you can now take these embeddings and use this as an input to, let's say, a classification model, or for a regression model, or for a clustering. You're free to use these features for any of those downstream tasks. Okay, so this was for text. So we just saw this for text. Now let us see for image. Image will also be very similar. And we will see one for audio. Okay. So let's do image. This is your image code, right? So we are going to use a ResNet 50 as a pre-trained model. Okay, I will, in the next class, we will have a list of, well-known models, and I will also give you the list of repositories where you can see these models. So for now, for image, we are again going to do the ResNet route. We are going to take the ResNet model, and we are going to set the model in the evaluation mode where it will give us the prediction. Then we perform some very simple transform on the model. We want to resize this image because ResNet accepts image with a specific size, which is 256 by 256. So we are going to, ResNet accepts, I think, 224. There is some standard dimension in which image should be present. So we are going to perform some of the basic transformation on the image, and then we are going to pass this particular image into the ResNet model, and we are going to take the features from this particular model. So we are going to perform pre-processing on the image. The pre-processing is defined over here, and then we are going to basically get the output of fourth layer of the model, and we are going to average, or we are going to get the average pooling of this model. So these are slightly advanced concepts which you will learn in deep learning course. And this particular average becomes the feature of our model. So in your work, what you need to basically do is, we are going to give you these type of codes. You just need to use these codes and get features, and treat this as a black box, get features, and then solve for other downstream tasks like classification, regression, clustering, any of those downstream tasks. Okay, now let's finally see. So can you work out on audio model, and we can discuss it in the next class. Think about, so do your research and find out what is the pre-trained, what model can we use as a pre-trained model for audio. And the audio model will also proceed in the same way. We'll select the audio model, we'll do any necessary pre-processing for this model, and then we are going to select the layer of this model from where we are going to read the output. We are going to take some kind of, probably the mean of those outputs, and that becomes our feature, right, for the audio model. So I hope now you got an idea of transfer learning and how can we use transfer learning for generating features for unstructured data types like text, images, audio, and videos. Right, for videos, again, you can think of a video as I said earlier, as a sequence of images. So you can take, you can get embedding for every image, and then you can possibly process those embeddings in some kind of a sequential manner, and then get predictions on the video. Okay. Okay, so in the next class, we will implement, we will implement classification task using the representations learned from these pre-trained models, and actually experience it in action. Okay, I'm going to stop here, Manoj, and take any questions that you may have. Any questions?
So next session will be on when you will conduct the next session, sir?
Next weekend, next Sunday, 11 o'clock.
Okay, sir.
So there's a question in the chat. Uh, what do we do if there are new words in the model which are not present in the pre-trained model?
That's an interesting problem. So there is something called as out of the vocabulary concept, and then we use that particular concept, or we sometimes ignore that word. That could be another way. Or in the model itself, we have a place for unknown words, where what we do is all low frequency words we mark them as unknown words, and the representation is learned from for them. So there are different strategies again.
So is there not a way we can feed our corpus to the model?
It is difficult because the model is already trained, right? So you are not retraining the model, right? So you're just using that model for prediction purposes. You're not training the model again.
Okay, sir.
If you train the model, that's a different story. But that is not possible. Other thing that you can do is there is something called as fine tuning of the model, which that concept you will learn in the deep learning class, where you can feed your own vocabulary to the model, and then you can try to fine tune this model. That is possible. So what happens is that last few layers of the models you can retrain with your own data set and your task. But we are not going to do that in this course, because here we just want to give you a tool by which you can get representation for text, images, audios, which are very interesting data sets for many of them and many of you. And right now you do not have any tool set to get features out of that. That's why we are handicapped. We are not able to solve problems on these data types. So we thought that we will give you some black box tools to generate features, and tell you something about what are the concepts behind them. Right? So that's why this transfer learning session. Does it make sense? Okay.
Yes, sir. Thank you.
Hello, sir.
Yes.
Sir, I was looking into a code by TensorFlow, sir.
Hmm.
So in that, what they were doing is they're making style transfer, sir. From one
Hmm.
image, the style is being transferred to other image.
Hmm.
So what they did is they used a pre-trained model, and
Hmm.
they extracted some features from a style image.
Hmm.
So what they did is they manually took a list of some layers, and they said that these layers are for style layers, and some other layers they said that these layers are for classification layers. So I did not understood. I did not understand how they said that these particular layers are belonging for style features, and these are for classification features, classification layers.
Hmm. So it could be, by doing some deeper study of the model, what kind of output it generates. Based on that, they might have, studied it, and then they might have. So they might, yeah, they would have done some deeper analysis using, through human experts, and then decided those layers as important for styles. So you can also do that. I mean, those are valid hacks or valid ways of generating features. Makes
Yeah, okay.
sense?
Oh, okay, sir. Got it.
Hello, sir.
Yes.
Sir, in case of YOLO, is it also an example of transfer learning if we don't train it on our images?
If you don't train on your images and if you use those models directly to get the prediction, it is not transfer learning. But if you use those models to get features and then you train your other model on the downstream task, then it becomes a transfer learning.
Okay, so even if I'm if I'm using that default model, then this is not transfer learning. But when I'm trying to train the model, it only learns the parameters from our images. So then it becomes transfer learning. Is it?
Yeah, so basically what happens is that you have, let's say, images, and you want to generate features for those images, right?
Yes.
So how can you do that right now? You can either manually inspect images and write down features, or apply some standard computer vision libraries to generate features, right? Or the third option is to use this transfer learning, where what you will do is you will basically use existing model or pre-trained model, right? You will take a pre-trained model and you will remove last few layers of the models, and you will pass the image to the model and you will read output of pre-selected layer, and that output will nothing but bunch of numbers, right? Those bunch of numbers you are going to use for, let's say, building a regression model or building a classification model, let's say logistic regression model, for example, right? So you can use those features, and that becomes your features, and then you train your logistic regression model on top of that, right? When you use YOLO, right, for object detection, you are basically feeding image and asking YOLO, do localize objects or tell me what objects are there.
Yes.
It is not exactly transfer learning. So you are basically using YOLO mainly for prediction. It's called zero shot.
Yes.
Zero shot prediction.
That's why I got confused, because when we use YOLO, we don't change the classification, the final.
Yeah. It's not really a transfer learning.
Okay. Thank you, sir.
This is a good question, by the way. I think Manoj has left. So let's stop this session today. Thank you very much for participating. I hope it was useful. Do you have any feedback about the way this was taught? I mean, I would appreciate honest feedback. I mean, even if it is bad. I mean, bad feedback is in fact more important, because then I can course correct it. You can also tell what worked well. Okay. Okay. Anything better you want me to do? And the speed is fine, right? Speed is fine, volume is fine.
Yes, sir.
Okay. Great. Thank you. We will then again meet next week, and we will do, hands-on practice of this. Okay, we might require a couple of more sessions. So if you can keep yourself free for next couple of weeks, that will be great. Thank you.
Thank you, sir.
Thanks, sir.
Thank you. Bye.
Thank you.
Have a nice weekend.
Thank
Bye.
you, sir.
Bye.